Okay, let's look at this question. We're warned that maybe we'll have to work backwards. Let's see what happens. So we've got tolls on a motorway. The number of cars arriving at a toll booth could be per 10 seconds. Oh, look, I'm counting cars arriving in 10 seconds. So this is events in a fixed time. So it's looking like it's going to be a poisson. Okay. It says modelled by a distribution with mean 3.4 per 10 seconds. So that's going to be my poisson. So X, which is the number of cars in 10 seconds, twiddles, I should say, a poisson with mean 3.4. Okay, check I don't have to change the time interval. This is 10-second interval, so that's great. I want there to be, okay, something happening in at least 85% of 10-second intervals. In other words, there's a probability that I need to be at least 85%, which is 0.85. Okay. All right. Now it's saying that the K toll booths are being installed. So this is a bit like the person running out of party bags. Okay. We're definitely looking at 10-second intervals. All right. It's just that the number of cars could be anything. Okay. Mean is going to be 3.4. There's some number of toll booths. And if I go above that number, then there are going to be cars waiting. Okay, so I don't want there to be cars waiting all that often. So therefore, I want the probability of X being less than or equal to K. All right. And that probability has to be, okay, at least 0.85. Okay. And this is the probability my calculator gives me. So this is a very rare occasion. I don't need the number line. Okay. The probability of the number of cars being less than or equal to K. In other words, they're not having to be cars waiting because I've built K toll booths. Okay. This probability I need to tabulate, and I'm going to have to do that for different values of K. So K, the value that I need to be less than or equal to on my Poisson screen, that's what goes in the X slot. And then my lambda is going to be a mean of this 3.4. Okay. But this will only do one probability at a time. So the smart thing to do is to start again with a Poisson distribution, Poisson CD, okay? But now I can do the list version of this, okay? So how many toll booths do I think I might need? Okay, well, if the average is 3.4, I'll need more than 3, but I could actually just do lots of values from 3 onwards. So if I have 4 or 5 or 6, the more toll booths I have, the better the chances that there are enough for the cars. The number of cars will be less than that value. 8, 9, 10. Okay, I've probably gone far enough. Okay, so now if I press equals, I just need to give the mean, which is 3.4, and then it will cleverly work out all of those values for me. I press equals. Here they are in the table, and I need to get my probability higher than 85%. And I need to show the value on either side. In fact, the only two I need to state are the probability of X being less than or equal to, that top value is 4, and that's 0.744. And then the probability of X being less than or equal to 5 is 0.8705. So 871, we think. Okay. 3 significant figures is okay, I think, in this particular case, because it's enough to show that this probability is high enough. So 5 toll booths is enough, but the 4 toll booths does not give a high enough probability. So therefore, we need to install 5 toll booths. There's my answer. It's good enough in context. So that's finished. Hooray.